Thank you for joining this episode of our webinar series on best practices in eDiscovery and digital forensics. Today's session is focused on a topic that's been in the news a lot lately: artificial intelligence advancements, and in particular, generative AI models and ChatGPT made a big splash in 2023. They're now poised to help automate many eDiscovery tasks. We're excited to show you how GenAI models like ChatGPT can become an extension of your team, automate eDiscovery tasks, and help you build better cases. My name is Jeff Fugit. I'm the Chief Revenue Officer for Lexby, and I'll be the moderator for today's event. We've got a ton of information to cover today, so I'll jump right in. Our webinars take place monthly and cover a variety of relevant eDiscovery and digital forensic topics, trends, best practices, and strategies. We've got limited seating, so be sure to register early for the sessions that are of interest to you. If you have technical issues or questions, please email us at webinars@lexby.com and we'll address those right away. Our webinars are available online at lexby.com for viewing via streaming video or downloadable as a PDF presentation or MP3 podcast. You'll find this webinar and a complete listing of other webinars at lexby.com and on our YouTube channel. If you have any questions during today's session, please enter them into the Q&A portion of the GoToWebinar console, and we'll answer those after the event. To be notified of future live and on-demand events, please email us at webinars@lexby.com or follow us on LinkedIn. For more than 18 years, Lexby's been helping legal teams with limited resources handle document-intensive matters. Nearly 9,000 legal professionals have come to rely on Lexby. We have the industry's most affordable and full-featured DIY cloud-based eDiscovery platform, and this includes integrations with ChatGPT and other generative AI models. We have the industry's fastest eDiscovery processing and document review platform, and this is important because being fast means you have more time to build a stronger case. We're consistently rated as having the best customer service and support, the easiest to administer, and the easiest to do business with. We've also been rated by G2 as delivering the fastest return on investment. We have a full forensic lab staffed with Celebrite and Magnet certified forensic investigators who perform full and targeted forensic collections and assist our clients with evidence acquisition. If you'd like a demonstration of our platform, simply email us at sales@lexby.com and we'll get that scheduled for you. We've got two guest speakers today. Gene Albert, the CEO of Lexby, is a former litigator and an expert in eDiscovery. He is a sought-after speaker on eDiscovery and legal tech topics. He's on the Planning Committee eDiscovery Institute for the State Bar of Texas. He has an MBA and BA from the University of Texas and a JD from SMU. Gene will be walking you through the basics of generative AI, the applicability to eDiscovery, measuring its performance, security issues, ethics, and case law. Joining Gene is Erica Biller. Erica is Lexby's product manager. She is highly experienced in law firm operations and eDiscovery. She is a litigation paralegal and is SED certified. Erica will be walking you through some specific use cases of GenAI and ChatGPT in eDiscovery and the benefits of that. Before I turn it over to Gene and Erica, I'm going to ask for your participation in a couple of polling questions. And our first polling question is, are you currently using ChatGPT or any other GenAI model in your legal practice? Yes, no, not yet, currently investigating. While you're answering that question, I'd like to thank you for participating in our polling questions today. All right, I'll go ahead and close that poll. And our next polling question: how do you think using ChatGPT and GenAI in eDiscovery will benefit your practice? Speed, cost savings, better insights, facilitating case strategy development, all the above, none of the above, or other? All right, I got a couple more answers coming in. And I'll go ahead and close that poll. And without further ado, I'll turn it over to Gene Albert. Gene?
Thank you for attending our webinar today. In the first part, I'm going to be speaking about background and key concepts having to do with the generative AI and eDiscovery and also speculating on some of the legal issues that have been raised by this. This is, of course, a dynamic area, and the technology and the law is changing at a very fast rate. So we will need to be updating this as we go along in the future. Secondly, there's just a lot of material here in this introductory webinar, so I'm going pretty quickly through some of it. If there's areas that you're interested in, you'd like us to explore in more detail, let us know in the comments. Also, there's going to be more detail in the slides. First, what is it? Well, it's the latest version of in artificial intelligence, and it's promising to revolutionize the eDiscovery workflows. It goes under different names, chatbots, LLMs for large language models. I'll talk about a little bit later. What's the promise? Well, it certainly has the opportunity and the possibility of certainly changing eDiscovery workflows in a way that we haven't seen in years, and possibly even revolutionizing it, depending on how the technology and the integrations work out. What's different this time? Well, we certainly have heard this before with AI, and it's certainly been disappointing to many that it didn't do more, or certainly versus the promises that were made about it. What's different this time? Well, the quality is much better, and it certainly has shocked a lot of data scientists in general and people in the e-discovery industry. And in particular, it provides greater functionality. Some of the previous versions of it were more of a black box of AI in general. And this one, for example, gives you reasons why it would determine that a document is responsive, summarize documents, and other things specific to e-discovery workflows that we think could have a big impact. Let's talk a little bit about the major players and companies that are involved in this technology. The one that made the big news in 2023 was OpenAI, which developed ChatGPT. They have had a lot of investment by Microsoft, which is a partner in that company. Anthropic is one where some of the engineers split off from OpenAI and developed that, and that's had a lot of development as well. Google Alphabet is creating one called Bard. Facebook Meta has one called Llama for large language models, LLM. And then Amazon AWS is developing Bedrock Titan, among other technologies, to implement different models. There's many more as well, but these are the largest ones. There's also a number of enterprises that have spent a lot of money developing their own in the many hundreds of millions of dollars in developing engines, including the large accounting firms. A number of e-discovery companies have developed their own models using earlier versions of the technology from several years ago without integrating ChatGPT or some of the more recent large models. We'll see if that holds up. And the reason for that is just how much money it takes to develop and maintain these. OpenAI alone has had over $10 billion in investment through 2023, and there are estimates of almost $20 billion investment in the industry so far today, and it's going at a very rapid rate now. So it's certainly going to be a large company game to perhaps to develop the main models. We'll see. And why is that? Well, part of the reason is how much data they're using to train and retrain. We don't have data on what's been done most recently because it's now treated as mainly proprietary. But for ChatGPT 3, which is one of the older models that OpenAI developed, you can see how much data they've trained on this. And of course, this has been spurring a number of copyright suits that are ongoing right now. But the tokens have to do with more or less a word. I'll explain that a little bit more in a minute. You can see that they took stuff off of the web, which was over 400 billion tokens, which are more or less words, which is everything they could find on that. Then they've got a number of books, which is where some of the copyright suits are coming out of. So over 60 billion words, more or less, from that, and then Wikipedia and others. So there's just a scope of this that we haven't seen anywhere else. Next, we'll go over some of the key terms and concepts that are involved. First is the term large language models, and this is AI systems that are trained on extensive data and text, and they are able to respond with human mimicking text and answers that seemingly are able to make pretty detailed and complicated inferences off of the data and words that they've been dealing with, all done on a statistical basis, but it sure seems to mimic human thought in many ways. Generative AI or GenAI is another term that's used for that. And with this one, it I think makes the point that it doesn't work just on language, but also on pictures and drawings and such that are interesting in a number of ways. These are all based on neural networks. And this is a type of machine learning that was developed a number of decades ago, but has been worked on that attempts to do programming in a way that mimics the way the human brain works using neurons and networks of neurons. Prompts is an important thing with GenAI models, that text or other inputs are sent into the model, and it utilizes that within limits that we'll talk about. Prompt engineering is the thought that these models' outputs are much more dependent on differences in the input, and sometimes seemingly minor differences in the input can have a big effect on the output. So you can get more or less out of the engine depending on how the prompts have been worded. This has started an idea of prompt engineering, which would be ways of doing prompts to get better output out of the engines. Let's talk a little bit more about how tokens and context window works. As mentioned, the tokens are a basic unit similar to text, and the difference will be sometimes punctuation could be counted, or a couple words might be grouped together for a concept token, but it's more or less text. And the context window has to do with the maximum amount that can be processed at one time out of the context window, which is analogous to short-term memory in humans, and the long-term, or computers, and the long-term memory would be what would be trained in the model, that would be underlying, that it has access to through the neural networks. As of the time of this webinar, the context windows, the short-term memory, depending on the different models and companies providing it, is anywhere between 16,000 tokens and 200,000 tokens. This will convert into something like 20 pages to several hundred pages of text, depending on the assumptions behind that, so you can kind of get an idea of what the short-term memory looks like. What's interesting and tricky with these models is that once the short-term memory or the context window has been exceeded, it loses whatever was in that memory. It still has the access to the underlying training that was done in the long-term memory in the neural networks, but it's bounded or limited by what it can access in the context window. How does that work? Well, looking at the graphic on the right, see that working on a timeline from left to right as it looks at the data coming in. On the far left, where it says 7 years, that could be the first part of a context window coming in. If it gets past whatever the context window was here, let's say 16,000 characters, and it moves on to the middle part that says, we're now engaged in a great civil war. If it didn't already know about this text, once it moves out of the token window from the 4 on the left, it wouldn't know that anymore. So it's a first in, first out system, similar to accounting. And then similarly, if the context window was too big, or if there's too much data went into the context window, it wouldn't get what was at the end of it, which would be, can long endure. This has to be managed, and just thinking how big the context window is and where you are and what data you put in. The systems themselves don't do this that well. Right now, they're pretty silent about that, but with integrations in eDiscovery, and of course, this has been managed. But it's good to keep that in mind. Now, the token windows, bigger is better, generally, yes, but if it gets too big, it slows it down, and there can be other issues with it under the models. So this is under active development for everybody to be managing the token and token windows and how this works in eDiscovery to make sure that we know what data comes in and we're using it all accurately to get the best results out of it. Grounding is another important concept in generative AI, and this refers to the ability of the model to point back to a specific document that correlates with its description and explanation of the source in whatever inferences it draws. This is different than the underlying search technology because the search by its nature will be able to point back to whatever document it pulled it from. But in generative AI, because the training is through neural networks, it loses those specific tiebacks to the underlying source document through the training by the nature of the technology. So in general with generative AI, because there is a desire to go back to the underlying documents, and with eDiscovery in particular, technology, when it's put into use, will go back and tie back into the original document in some fashion. On the right here, this is out of one of the search engines that are doing this now, Bing, so you can see how they've done that. But it's a different process where they go back and use search or something else to find out what document that probably came from, since it's not inherently out of the generative AI engine. A second concept is what's being called zero retention APIs. As generative AI models are integrated into other software, there's a desire to not use the data for training. And the zero retention APIs are an answer to that. And then we'll go to the next slide and talk about some of the details of what these policies look like. How these models use the prompt data for their training has been the issue of the day with this technology and is, of course, of critical importance in eDiscovery even more than other areas. The background for this is that the models and the companies developing these are hungry for all the training data they can get, and a very valuable source of training data is feedback from users and the questions that are asked in prompts. And certainly seen this with similar versions of, or previous versions of this technology that were used, that were recommendation engines for music and other media that we'll see on Amazon or other Spotify or other services like that. And that's where a lot of their training comes from. Not having to have that makes that more expensive for them to keep these models up to date and be competitive. But, of course, that doesn't work for eDiscovery or for business. So the companies have made commitments not to do that, and it's being called zero data APIs. And this is, in many respects, similar to what you'd expect for cloud storage and business usage for Microsoft or Google, to where they make a commitment that they won't use the data or store it beyond your own usage of it sometimes. So the sort of terms you'd see in a zero data API are on the left there that would include, here, no data storage, transient processing, other similar things. The companies have so far tended to make that the zero data APIs and these security commitments only for commercial accounts or APIs. So generally, if you're under a subscription account or an API, they are committing to not use the data, but that's certainly something that needs to be checked in the eDiscovery and legal environment. The next important concept to discuss is what's known as hallucinations. And this is the tendency of these models to sometimes come up with answers that aren't justifiable, seemingly not a justifiable inference from the data that they're working with. And this could come from a number of different reasons and sources that are difficult to track down for the model developers. But from the end user's point of view, it just comes out with something that just looks incorrect, and we don't understand how it got to that answer specifically. But this is really just a type of a false positive that we certainly see in other computer models or other inferences. How do you avoid it? Well, I think with these models, more than search, you need to verify your responses, and that's why using the grounding is important to be able to get back to that. And some thought and work needs to go into the proper prompt construction in the first place that can also have an effect on its tendencies to generate hallucinations. That leads us into what the ethical obligations are with this new technology. There haven't been a lot of specific rules on this so far because it's new, but the existing rules apply and are, as one would expect, that the rules with technology provide that one needs to keep up with technology and can't ignore it. And there isn't a prohibition at all, except the opposite, where there's an obligation to keep up with it. You can see in the ABA rules, particularly Model Rule 1.1. There are starting to be some state bar rules as well, and you can see on the right there's a Florida advisory opinion that goes through, what you'd expect with it, particularly focusing on the standard rules having to do with security and competence and keeping up with technology and taking the risks and benefits into account. And I expect we'll see the same thing in the future. There was an incident having to do with hallucinations in mid-2023 that got a lot of news that y'all probably heard about, but let me address it quickly, that there were some attorneys that were experimenting around with using the technology, and they were using it for case research for their briefs, and they apparently came up with some cites that were incorrect and filed them in a court proceeding and were sanctioned for this as they should have been. But that has certainly raised this issue for hallucinations, at least in that aspect, for judges and others. And some courts have started adding local rules saying that you can't use GenAI for legal research or similar functions, but this doesn't directly impact eDiscovery at all. In the next slide, I want to talk a little bit about court acceptance of generative AI and large language models in eDiscovery context. And I would distinguish between different use cases that shouldn't be confused. First one that shouldn't be confused is the previous slide, which is somebody using it for brief writing or misusing it for brief writing. This is a completely different case over here because we're working with established eDiscovery workflows and not using it for drafting or brief writing. I think that is a very different case. The first eDiscovery use case would be to use it in what we call copilot mode, perhaps a document at a time or several documents at a time. And this is where it's being used with the reviewing attorney, and it's a technology tool to make the attorney more efficient. And in this way, it's similar to search or computers in general, and just part of the attorney doing their job in the current world. So I don't see any particular legal cases that are going to come up with that other than just proper use and supervision. Second use case is what we're calling autopilot mode, and that's where one might use the technology to go through and classify a number of documents or all documents in the case as to responsiveness or privilege or other confidentiality, PII, other workflows. And we'll show some examples of that later. Here, in this situation, this is being used as a way of prioritizing review by the attorneys, and the attorney will go through and look at documents. Now, in this case, I think, again, this doesn't raise very many issues that we don't already have in search. It's been a long time since anyone thought there was any requirement that attorneys should look eyes on all documents in a matter. And search is used and tested in various ways to determine if it's appropriate for production using proportionality and other concepts. And it's a good idea to test your output, and that can be structured or unstructured. That's done all the time in cases. And I don't see that this is really going to be any different, or that it could be any different than that. That's the way to use the technology is to make it to where the attorney doesn't have to do everything himself or herself. And I think we'll see a similar analysis here. The third case is also autopilot mode, but this is what's been used with TAR previously over the last 5 to 10 years, to where there might be no attorney review, or the review of the documents will be structured and statistical to determine if the model there in that case has been appropriately trained and if it's appropriate for production. And there the courts have looked at the process to see if it's a proper process, but also have looked at specific targets for precision recall and F1 score, which I'll talk about in a second, which is a combination of those. I think we'll see a similar analysis here with ChatGPT when it's used in that case, and that it will do very well because it seems to do as well on precision recall and the F1 score as the previous legacy TAR and humans for that case. Precision and recall are statistical measures of adequacy of production in eDiscovery situations, and I think they'll be used in generative AI as they've been used in TAR as well. The first situation is theoretical ideal, which is perfect precision and recall. That would be the upper left, where everything that was produced was responsive and nothing that was not responsive was produced. The second lower left would be an underproduction, and that's low precision and high recall. So in this one, there are excessive false negatives. So what was produced was indeed relevant. You can see the green boxes, but things that were relevant were missed. The third situation on the upper right is overproduction, and this is high precision, low recall. And here, nothing was missed, but certainly a lot was produced that was not responsive. And this is a data dump, and one can always get to a perfect high precision, low recall by just producing everything in the case. But of course, that would be a data dump and it would be improper. But that is the excessive false positive. And then the last one is low precision, low recall. And that's where there's non-responsive are being produced and also responsive. And this is, if there's too much of this, is just junk. But in the usual case, this is what happens all the time, is that there can't be perfect precision and recall, and if you don't produce everything, then you're going to have some mixture of precision and recall. Next, there's a slide that illustrates the F1 calculation, and this is a derivative statistics used to combine precision and recall, which we discussed in the previous slide. So the precision and recall is measured on a 1 to 100% measure or 0 to 1. You can see on the left columns, and then that's combined into an average score, which is the F1. And this is a little bit different than our usual average, which is because it's called a harmonic mean, which isn't important for this right here, but it is less sensitive to outliers, and it quantifies a combination of precision and recall. And there's usually a trade-off between precision and recall, and this has been illustrated in the TAR case law, so it doesn't tell you if it's high precision or high recall. The various ones could combine into a single F1 score. But the 0.7 where I have certainly is a target that's mentioned in some of the literature, and these are the sort of scores that have been looked for in the previous case law when using TAR or when doing regular search reviews. An important issue in connection with evaluating generative AI in an automated eDiscovery context is how well the technology performs versus humans. We tend to think, as part of our cognitive bias, that humans perform very well, if not perfectly, in situations, but the research doesn't support that. There was a 2010 study suggesting that humans' accuracy on review type situation is only about 50%, even though we think it's much, much higher. The TREC proceedings, which was a government-sponsored research project having to do with TAR technology, showed only about a 57% recall rate in conjunction with search. Precision is really no better. It tends to be a trade-off between recall and precision in the study. The higher the recall, the lower the precision. There's a trade-off between the two. A broader search is higher recall, low precision. Narrow search is lower recall and high precision. So on the human versus machine, at least on the studies, there really is no gold standard, and that reviewers, even qualified reviewers, may differ between themselves as much as 30% of the time as to a classification. So we tend to think of humans and attorneys in eDiscovery as being a real gold standard, but we're probably a 10 standard at best. So that leads to the applicability of the existing TAR case law to generative AI uses for automated classification in conjunction with productions. What will the courts do? Well, I think they will apply the TAR case law. This is really just another type of technology-assisted review with different technology, and that's, I think, the way the courts will look at it. The courts have been tended to support TAR usage very, very much, and they do that, I believe, because they're worried about what will happen to our court system with the increased number of documents if we don't use technology to deal with the documents that technology has brought us. But they're loath to set or require specific targets. They don't want to get their hands dirty very, very much, with some few notable exceptions. So I think the cases tend to follow ESI orders and protocols closely. So if one does identify using any kind of production technology in an ESI order, the courts will tend to enforce it without too many questions, and don't want to jump into the details of that. The early cases having to do with TAR technology tended to focus on the specific technologies and the procedures used, but the later cases don't get into the details of that as much, and instead look at the output and testing. And this is where the precision recall and F1 score come in. The cases don't so much dictate a specific precision or recall or F1, but some of them have approved or have certainly dealt with cases that have been in areas of specific targets. So there's one case, Lawson, that was talking about an 85% recall rate that thought was reasonable. And then in another case, precision in the ESI order had been targeted at 85% and it wasn't met at 57%. And discovery was extended to allow more time for production in conjunction with a targeted ESI order. The next slide are a few current practice recommendations that I summarized from current publications by people who are actively working in this area. And I think this will likely be applied to the generative AI technology-assisted review as well. They certainly look closely at the recall and precision scores and using the F1 to combine them, and that a target in the range of 70 to 80% for a recall would be a good target that a court would support. Precision might be targeted at 70% as well, but that tends to vary more than the targets for recall because of the trade-off between the two, and between the two, the courts will prioritize having a better recall estimate as being more valid to actually get the evidence, and dropping off on precision that's a good trade-off up to a point where it's some sort of data dump. The next slide shows some testing that we did internally on F1 scores for generative AI compared between the different models that are out there and humans. And this is why we and others are so excited about this technology. You can see with the red line that is 70%, that 70 to 80% goal is to where many of the practitioners and courts have looked in conjunction with the previous legacy TAR. And you can see that the generative AI models do very, very well against humans and the different models that are out there. So they seem to all be within the range that are very competitive with humans. We've seen in other studies. It generally is usually meeting a 70% plus F1 target. And the advantage of the generative AI over the previous TAR is that this can give a confidence level, but also explain the confidence level and provide document summaries, which we didn't have with the other technology. So I think this will end up displacing that over time. This is all still improving all the time. We're seeing better and better results as the new engines are released through 2024. And lastly, for my part of the webinar, is one does need to do some statistical sampling if it's being used on an automated basis. So you need a way of gathering that and being able to document it in some fashion. So you can see here how we've done that within Lexby, showing the precision and recall against human testing, and then what the false rate is, and then that will combine into an F1 score. So that this or something similar should be used in conjunction with using it on an automated basis, although if one was using it simply as a co-pilot, I don't think any of this is legally required. And with that, I will turn it over to Erica to talk about some more specifics, how we've implemented this within the Lexby eDiscovery platform. Thank you for your attention.
So what are some use cases that AI can be used in for eDiscovery? The first one that we're going to touch on is determining relevancy or responsiveness. Now, we're approaching this from the perspective of utilizing generative AI to help conduct a first level review. So essentially, we've put together a prompt here, and we have a topic, and then we're asking the AI to respond yes or no. So either the document is responsive to this topic or not responsive. And then we're asking it to give a confidence rating of its assessment based on a scale of 1 to 10, with 10 being the most confident and 1 being the least confident. And we've also asked for a brief summary as to why it has made the assessment it has. And we've also specified a format for the output of its response. As you can see, the AI determined that this document was responsive to this particular topic. It had a confidence level of 9, and then it also provided us with the brief summary that we requested, and it gave us the overall response in the format that we requested as well. So when we look at this from the perspective of a first level review, imagine running this prompt across all of the documents in your data set, and then taking the documents that have a confidence level of, say, 8, 9, or 10, promoting those to the next level of review, and then maybe taking documents with a confidence level of 7 or lower and either maybe doing some extra searches on them or generally just putting another set of eyes on those documents before you make the determination as to whether or not you want to go ahead and promote them to the next level of review. Obviously, implementation of AI in this manner is going to substantially reduce your costs and put you significantly ahead of schedule because we're looking at a first level review being completed in really 24 hours. The next use case that we are going to touch on is personally identifiable information, also known as PII. We have certainly all struggled at some point with having to identify it and get it redacted out of our data sets in preparation for either being used as exhibits or being produced to other parties. So sometimes we're fortunate enough that we know exactly what we're looking for with PII. We know all of the types of documents that we have and what's going to need to be redacted from them and where to find it. However, we're not always so fortunate. So you can really craft a prompt if you don't have a good grasp on what type of PII you're necessarily looking for or dealing with in your data set. You can put together a prompt and ask it, hey, what types of PII are in this group of documents? And it'll provide you with a list. Again, you can be specific if you want. You can see here in the example on the slide that we have specifically asked for email addresses, social security numbers, and phone numbers, which is precisely what it gave us. And that was off a basic patient intake form. But again, if you don't know what you're looking for, you can ask for it to provide it to you, what it believes is PII. And then you can actually go a step further and ask for it to provide it to you in a specific format. So as we all know, phone numbers are never written in a consistent format. You know, area codes have parentheses around them. Sometimes they don't. Sometimes email addresses, if they've gone through processing, they'll have parentheses around them and then a name. Sometimes you've got a semicolon after it. You can write into your prompt that all of these things be normalized and then deduplicated so you end up with a single list of the unique PII that you need to be looking for across your data set. The next use case that we're going to look at is using generative AI for document translation. A lot of times we're fortunate to know on the front end during the collection phase whether or not we're going to have a large set of foreign language documents that we're going to have to contend with. With LexiB Copilot and Autopilot, we can process foreign language documents and translate them either in mass or, as we have on the slide here, on a document by document basis. A simple request or a prompt of please translate this document into English is what we used, and you can see the response that we got on the right-hand side. Again, if you know that you have a lot of foreign language documents that are going to be in your review, you can run the prompt against all of those at once. Or if you're reviewing what you think are primarily English documents, and then you happen to come across a rogue foreign language document, you can always run this on the fly just so you can go ahead, get through your review, and move on to the next document. The next use case seems to be a favorite among those that I've spoken with, and I certainly wish that it would have existed back when I was working in a law firm. That's going to be the ability to summarize hearing transcripts and deposition transcripts. Obviously, you can use AI for all sorts of summarization and document analysis, but we have certainly all been responsible at one point or another, I would imagine, with having to summarize deposition transcripts. Somebody has to do the dirty work. And so now we can have AI do it for us. So here we just, again, a very simple prompt. Please summarize this trial transcript that we have here. And that's exactly what it does. And it does it pretty quickly. And you also have the ability, if you have, say, multiple transcripts, using Lexby Copilot, you can select multiple transcripts or documents that you want summarized, and it will run through and create summaries for each. It can also, if you select multiple ones, take essentially the text from all of those and build a summary of those 10 documents in aggregate. So it's something to consider. Absolutely one of the most useful aspects, I think, of AI in eDiscovery. The next case the next use case we're going to look at for generative AI and eDiscovery is going to be IDing key dates and entities. And really, this kind of gets into some early case assessment work or tools. And with generative AI and how broad its functionality is, it's really a fully customizable analytics tool. Again, this particular example is for key dates and entities, but you can really make it anything that you need. So in this particular example, we actually selected 10 documents just randomly, and then we asked it to identify the key dates as well as the key entities in those documents, and then provide us with a summary of those 10 documents as well. So again, while this is just one example of what it can do, early case assessment analytics in general, with how customizable Gen AI is, really there is no limit to the kind of information that you could probably use this to generate. So the final use case is my favorite. I've saved the best for last, and that is using generative AI to create chronologies. Certainly, if you've worked in the legal field, in a law firm, whether you're an attorney or a paralegal, we have all been tasked with creating a chronology, a timeline, whether you're sifting through a few documents, looking for a few key events, or you have had a data dump and it is now your fun task to get everything in order and figure out what's actually going on. Now, instead of having to labor intensively for days and days trying to get things in order and manually creating a timeline or a chronology, you can do it literally within a minute or two. You'll see in this particular example, we used only one document. However, what's unique about it is that this document it wasn't a document that would be used to be timelined in a sense that you would normally think of. And it actually mentions here, so we inputted our prompt, create a chronology of the key events in this document. And so it lets us know what this document is, but it also mentions that the key events and data points in the document are not events in the traditional sense, but are statistical updates and activities related to the direct access program as of specific dates. So again, these aren't dates in the traditional sense. It goes through and it timelines what are essentially these statistical updates and activities. And then to add even further context to the timeline, at the end, it states that the document does not provide specific events in a narrative form, but rather gives a snapshot of the direct access program status at the end of August 2001 and the activities related to the program within that month. So, every time I've ever created a chronology in the past, you go through diligently, create your entries and whatnot, but literally within certainly less than a minute, it spit out a chronology, and it even gave us context as to why these dates are not what you would traditionally see in a document chronology. So again, this was on one document. However, you can select however many documents you would want in the case and say, hey, create a chronology of the key events in this document. and it will go ahead and generate one for you. And that particular use case is one of my all-time favorites, and I absolutely wish that it existed back when I was working in a law firm. So just absolutely I think, one of the biggest time savers that generative AI can provide us for use in eDiscovery.
Thanks, Erica, for walking us through those use cases. And thank you, Gene, for giving us the foundations of generative AI and eDiscovery. It's really amazing to see how ChatGPT can be utilized in eDiscovery and help lawyers and paralegals handle those document-intensive matters and more diverse cases and really facilitate the process of building a strong case. It's pretty incredible. As I mentioned in the introduction, we have an advanced forensic lab equipped with the latest tools to help collect the documents you need for your cases. We perform remote and on-site collections and have performed collections from all kinds of sources, as you can see on this partial list. If you need to find deleted text messages or collect data from sources like Slack or Microsoft Teams, then we're here to help. And that leads me to our next polling question. Do you have a digital forensic project, and would you like a complimentary consult? All right, and I'll go ahead and close that poll. We work with a lot of litigators to help them solve their eDiscovery challenges. Jordan Howlett is a sophisticated litigator running a multi-office boutique firm. Most of his cases involve larger, well-funded opposition. With Lexby, he likes having the ChatGPT integration available at his fingertips so he can quickly gain insights into the relevant case documents and is better equipped for building a strong case. David Jones was concerned that he would be outgunned by his AmLaw opposition. He quickly realized that Lexby is a great equalizer and helped him build his best case that delivered a winning verdict. Paige Tackett at Thompson Co. needed Lexby's speed to get some productions out the door to meet deadlines. Lexby is lightning fast and gets you from document ingestion to productions faster. Patrick Biggins needed an easy-to-use eDiscovery platform to handle some document-intensive cases. Lexby got him onboarded fast and provided the support they needed to build a strong case. With Lexby's eDiscovery platform hosted at Amazon Web Services, you get on-demand capabilities that scale to address the needs of your case. With our cloud infrastructure, you can get from document ingestion to review faster and get your productions out the door faster. All of your remote or mobile connected employees can access the Lexby eDiscovery platform via web browser. It works great on Macs, PCs, iPhones, and Android devices. This gives you unprecedented flexibility and efficiency. And I wanted to point out that Lexby is a single end-to-end eDiscovery platform, and we've got a complete ChatGPT integration, as you saw in the use cases that Erica walked through. Unlike many eDiscovery providers, you don't have to move your data from one solution to another. It's fully integrated, and you get processing, you get advanced analytics, you get powerful search capabilities, you get a flexible document review workflow so you can structure it in a way that works best for your firm. You've got a case timeline builder, easily manage your productions, and we also have best-in-class security and powerful administrative controls, all at your fingertips. And with that, I'll ask our last polling question. Would you like a demo of the Lexby eDiscovery platform? While you're answering that, I'd like to thank you for attending today's session. We'll be making the following available to webinar attendees: a recorded streaming version, an MP3 podcast, as well as a PDF. Please let us know if you have any questions or comments about this webinar or suggestions for future topics. There will be a survey at the end of today's session, and it helps us to continuously improve this program and cover the digital forensic and eDiscovery topics that are most relevant to you. So please answer the questions at the end of the session today. This webinar is part of the Lexby eDiscovery webinar series. For notices of future live and on-demand webinars as part of this series, please email us at webinars@lexby.com or follow us on LinkedIn. And with that, I'd like to thank Jean and Erica for presenting today, and thank you for attending. Be sure to follow Lexby on LinkedIn so you'll be alerted to the latest podcast and webinar episodes, and watch your inbox for an invite to our next webinar on best practices in eDiscovery and digital forensics. Take care.